Those limiting reactant questions started off with solutions. This one is not based on solution. Take a look at the first line of this question. It says that the calcium is present in the mass in grams, that is 4.8 grams, and the water is just 3.6 grams, which means we cannot use the concentration formula. Since both the quantities are given in terms of mass in grams, so it would be a very simple formula. Moles is equal to mass over mR. So you need to calculate the mR for water, the AR for calcium. You may look it up in the periodic table. And then from those parts, you can easily solve your part one of this question. So go ahead, give it a try. At least let me know what the answers to part one is. I can wait. Take your time. There, the number of moles of calcium and number of moles of water. Now, can you identify the reagent which is in excess and then explain your choice? Now, since he asks you to identify the reagent in excess and explain your choice, that means you need to name or formulate the reagent that is in excess and to use the rest of the two lines to explain why you have chosen this reagent to be in excess. And not just that, if you read out part C, it says that calculate the mass of the reagent named in 2, which definitely is the excess reagent, remained at the end of the experiment. This is exactly the question I'm talking about, that we need to calculate the mass of the excess reagent left unreacted. So the mass of the excess reagent left unreacted cannot be written as an explanation to our choice in this part. Why? Because we are supposed to write this one over here. So for this choice's explanation, we need to simply come up with the figures before the left unreacted part. So go ahead, take your time, try solving part two.
Moles as the divisor.
Yeah, and what happens? Since the numbers are same, and the number of moles of CaOH twice would also be same, which means 0.12 moles of calcium produce 0.12 moles of calcium hydroxide, CaOH twice. Isn't that your answer?
Yes, sir.
Then yeah, that's correct. Go ahead, do the same thing with water. H2O ratio CaOH twice. That would actually give you the ease of identifying either one of them as limiting or as excess reagent. There you go. You've already solved half of part two. Actually, the whole part two, because then you can put these numbers in part two as your explanation of your choice, and then you'll be done with the whole 2 marks. Go ahead. Since you're at the right path already, I think you would easily be able to do it correctly. Take your time. Two. So you are already done with the ratio of Ca and you took the product CaOH twice. You took it as 1:1 and your answer to 0.12 was of course X, which would be equal to 0.12 mole. Now this produces 0.12 mole of CaOH twice as a product if we consider this one as a point of perception. The other one would be H2O ratio CaOH twice as a product, and that would be 2:1 from a balanced chemical equation. And since you used 0.1, the X would be equal to 0.1 divided by 2, answer to which is, oh, this is 0.2, my bad. This is not 0.1, this is 0.2. The answer comes out to be 0.1 mole CaOH twice. Now, which one produces lesser number of moles of product?
Sir,
The top calculation or bottom calculation?
sir, the bottom calculation of CaOH2, which is 0.10.
Yeah, this one is lesser number of moles, which proves water to be our limiting reactant. And automatically, calcium would be excess reactant. Now, since we have everything mentioned in front of us, how would you structure your answer to part two? Because you obviously know which one is the excess reactant and why. You have all the numbers to discuss your answer for 2 marks. Go ahead. How would you compose your answer?
Um, sir, a question, sir. Won't we also there's another step, right, when we're trying to find the excess and the ER and LR, and at the least the last step would be LR ratio ER. Won't we do that?
Yeah, you can do that, but actually you need that for step three. So yeah, go ahead with the whole thing, but that would actually help you for step three. So far, what we have done can allow us to um, go for our answer for part two. But if you need some more numbers to code in part two, of course you can go with that step two. It's entirely up to the student which figures or which numbers he want to use. For example, let's say you want to solve the limiting reactant LR ratio ER, and then you want to use those numbers in your answer in part two. You can do that too. If you want to do that, go ahead. That's completely fine by me because the answers can be structured or composed in many ways. There are many figures in the question that you can use to hint or to explain your choice, which is given in part two. And you're going to see the same thing in marking scheme as well. So go ahead. Whatever you like to do, you can. I can wait. Actually, coded. Don't forget there is this LR ratio ER step, and I hope you have done it. So since the LR is water, so we're going to put water over here, and ER is calcium, we're going to put calcium over here. Since water is 2 ratio 1, and this one is number of moles of water is 0.2, and calcium is would be X. So let's find out this X. That would
Yes,
be
sir.
2.
I'm getting the answer now. I'm getting the answer 0.05 moles left.
Um, no, I don't think that is right. Well, this is going to be 0.2 over 2, and this would be 0.1 mole of calcium. So that is calcium consumed. Okay. So remember, this was the total amount of calcium. So total minus consumed is equal to left unreacted. And this left unreacted, since we have 0.12 moles at the start of the question, and the third part tells us that we have used 0.1 out of that, so the answer is 0.02 moles. 0.02 moles of calcium would left unreacted at the end of the whole experiment, right?
Sir, I'm kind of confused. I don't know, but because I understand that your first whole we use the ratio two, ratio one, but I'm kind of confused. Why are we using 0.2?
Because that's water, and the number of moles of water are 0.2,
Oh, yeah, okay.
right? Because this tells us we need to, this LR ratio ER or limiting reactant ratio excess reactant tells us if we completely use all of our limiting reactant and the maximum amount of water in the question is 0.2 moles, if we completely use all of that, how much of the calcium or excess reactant would be used? And this tells us out of 0.12 moles, we're only going to use 0.1 moles. So we subtracted 0.12 and zero point 0.1 in order to get the amount of left unreacted for excess reactant, that is calcium. So, okay, so the three parts done on the left can help you compose your answer for part two. The one part done on right can help you compose your answer to part three. Compose your answers, write complete whole two sentences both for part two and part three, and then get back to me and we can discuss it whether the words you have chosen, the figures you have written are going to be the right choice for answer of part two and three or not. Go ahead.
Just one more thing, sir. I just realized right now the mistake I made. It's kind of silly, but I used the part two's answers as you know, in the ratio process. I used those rather than using the original moles that I found out in part one. That's where I made the mistake.
All right. So you must have been using the number of moles of product instead of the number of moles of reactant in the last part. So yeah, that is sometimes the student tend to make the mistake. Now, the reason I have been writing, and I'm going to point it out by underlining it with red, this answer, I specifically write CAOH next to it, or this answer, or I write specifically CAOH next to it, so that you don't use it in LR ratio ER. Why CAOH choice is the product? And why would we use the amount of product in the calculation of reactants when they are compared with one another? That's why I tend to write the names next to the quantities so that I never confuse them with the usage of the quantity of the product instead of the quantity of the reactant, right?
Yes, sir.
So I hope this gives you the idea why we actually put the wrong, sometimes put the wrong digits in the wrong choice or the wrong place. And that's what we do because we don't specify what they are. So I have been with each and every single one of my answers. Look, I have specified this answer is for CA's choice, this is for CA's choice, this is for CA alone, and this is for CA alone. And I have been doing it real recently just to make sure that you don't use the wrong numbers with the wrong species. Okay. And if you're going to put it as your habit, it is going to help you avoid mistakes. The point I was trying to make this whole time is that if you are going to make it a habit of yours, this is going to keep you away from mistakes because then you would know exactly which number belongs to which species. Make sense?
Yes, sir.
Great, great. Go ahead, formulate your answer to part two and three, and then we can going to finalize this whole question.
And using the ratio of H2O ratio CaOH square uh, which gives us 0.10, we conclude that the latter 0.10 is the excess since it's the smallest of the bunch.
But the latter is limiting reactant, and you need to identify the excess reactant.
Yes, yes, sir. Since
Former,
okay,
the former is 0.1 mole. But don't you think that's too long of an answer? How would you wind this answer up in just two lines in the given space? You would be using much more space.
yes, sir, exactly.
So it's really better if you don't put it in words, instead put it in the form of maths over here. I mean, you can simply write the whole stuff over here like this, right? And 1:1, this is 0.12 ratio 0x, which is equal to 0.12. But that's not what we are supposed to do. So another good approach towards this, first of all, there are two questions in here, two statements, I mean, excess and this one. So first of all, you need to put CA is in excess. That is actually the answer to the first part. And then you can explain your choice. You can simply write it produces 0.12 mole of the AOH twice, while H2O produces 0.1 mole of COH twice. This is going to give examiner the idea that you have done the whole two ratios to solve the answer. You don't necessarily need to mention your steps in the answer. However, you can mention your answer in the given space as an actual answer to the question. Make sense? And I have written it a whole lot wider. I have tend to use more space than actually what I could have, which means I've used a bigger font, to be honest.
So, sir, the appropriate technique would be rather than explaining the answer to the examiner, I should just provide the facts.
Yeah, provide the figures. Providing the figures actually gives the examiner the idea that you have worked upon them. How did you come up with the figure? You didn't guess it, right? You actually had a mathematical procedure to go with before you can come up with that answer. So providing that answer in the given space gives the examiner the idea that you have definitely went through the steps of solution. And that's good enough of a proof. How can one come up with 0.12 and 0.1 if they haven't worked it out? Because 0.1 and 0.12 are not the part of the questions. You can't just come up with numbers unless you have done any steps of the solution, right? So what about part three?
Sir, just a second, sir. I'll answer part three.
Sure, compose your answer. When you're ready, let me know. I'm here. So yeah, 0.02 mole of calcium is the perfect answer. And yeah, 1 mark is for the correct answer after the calculation. Since you have calculated everything, just putting your answer gives the examiner the idea that you've done it correctly, right?
But sir, hypothetically, if it says 2 marks and it demands an explanation, how would you compose the answer, sir?
The exact thing that I wrote in the last steps. Total
Also,
moles
we
of
don't really
calcium
have to mention.
0.12, consumed moles 0.1, left unreacted this. Just like I did last time. Just put all three values in there, the total number of moles of calcium, the consumed number of moles of calcium, and the left unreacted number of moles of calcium. That way you're going to get 2 marks.
We don't have to really mention the LR ratio ER and find GX.
No, you don't need to mention this one because this works as a prerequisite. Actually, the specific part talks about the amount of ER left unreacted. So how did you calculate consume or how did you calculate the total does not matter to them. Otherwise, we calculated the total with the help of formula. Why aren't we mentioning it then? So there is no need how you calculated total. This was the way you calculated total. This was the entire way you calculated consumed. So you might just mention the method to work out the consumed. Why not the total then? So since we're not doing both of them, we are just discussing the subtraction part to give examiner the idea that there are three values we need to work with. Total and consumed subtracted from it, which gives us the left unreacted amount, since he's interested in the left unreacted amount,
Okay, sir.
which gives, which actually proves the point I'm trying to make. And the whole point I'm trying to make is that sometimes the last part is the most important part, or the part examiner is talking about is the most important part. Discussing that part as a part of your explanation gives the examiner the idea that you must have done the prerequisites already. So you don't need to talk about what your prerequisites were, right?
Yes,
So
sir.
when you sit in Cambridge exams, Cambridge automatically assumes that you must have done your class 1, 2, 3, 4, 5, 6, 7, 8, and so on. That's why you're sitting in your class 10 or 11 exams to complete your Cambridge IGCSE. They don't ask you about the prerequisite. They simply ask you to take the exams, and if you do good enough in the exams, they already understand that you must have completed the prerequisite, how far you were able to come sincere, right? So it makes the whole point automatically. Are we good?
Yes, sir.
Great. So can I raise this
Yes,
all?
sir, if it's possible, could you send this on WhatsApp?
Yeah, sure. I am going to take a picture. I'll send the picture later. I'm going to clear all of this up. Okay. And the reason I wanted to move ahead is that I wanted to pick another question out and I wanted to give you that as a homework. Now, this question, this is probably the second last page of this worksheet, probably the last one. Yeah, this is the last page, not the second last one. And this is the very last portion of the entire worksheet. This again belongs to limiting reactants. So they have given you a big whole writing space, 3 marks, identify the limiting reactant and explain your choice. Now, the moles of silicon have already been given, so you don't need to work with them. The moles of bromine is something that you're going to find out. And then you're also going to tell them how many moles of the product are formed. So this really does not require any calculation of the excess reactant, which means LR ratio ER or subtraction of total and consumed is not required for this question. This first two steps, the first two ratios are what you're required to do in this question. And that's about it for both the parts, right? So go ahead, take it as a homework, and I hope you will be able to do it correctly.